Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd better take a look at the main board out of that 286 PC. I've already taken it out of the case and put all the drives back in the case loosely and put it away for storage for the moment, so we can just concentrate on the main board. Let me get you zoomed down. You can see quite how horrendous this corrosion is. Let me see if I can get you down a little bit more, like that. There we go, that gives you a good indication. Oops, right, so you can see the extent of the damage. It pretty much goes from the end of the power connector there, under that IC there. I think it might have just grazed that there, which I think is the keyboard controller. These glue logic there are absolutely covered, and it's all down to our old friend the Vata battery there. I think the first thing we should do before we do anything else is get that off the board. Yeah, it's even come right through, and it's come through some of the wires, and it's done quite a bit of damage on the back of the board as well. This one's going to be a challenge to save, to be honest. We'll give it our best to see what we can do with it, but there does look to be an awful lot of damage. Let's get some equipment out. We'll need some solder. We'll get all the good stuff out, I think. Solder, braid, we'll get some fluxers. Right, okay. We've got a manual pump in here. We can always pull out the electric desoldering pump if we want. Right, I think first things first, let's have a little bit of a clean up. Let's get some white vinegar. I'm going to have a bit of a clean up before I even attempt to try and remove that battery, just so we can actually see the solder, because at the moment all I can see is green corrosion. So just dip a little bit on the board like that. You see that fizzing almost instantly as soon as we stuck it on there. I'm hoping at the very least, like I said, we can just neutralise some of the worst of the corrosion. It has actually come off the solder points there, which is good. To try to remove them a little bit easier anyway, if nothing else. Just realised, where's my tissue gone? Oh, where's the tissue gone? I'll have to use Q-tips. Where have my Q-tips gone? Oh, there they are. See, a lot of that's actually come off on the back of the board, but the back of the board, I mean, there's a very, very corroded wire there. The one right there is incredibly corroded. It's got under the solder mask in a few places, and there's a few places it looks a bit grim where we're going to have to test continuity on the tracers. But at least the solder points around that battery have cleaned up a bit. Let's add a bit of flux to them. Get some solder, and we'll try adding a bit of fresh solder to them, see if we can get them to soften up. Then hopefully we can pull that battery out. If not, we'll have to cut it off from the other side and then worry about getting the bits out after that. A nice big tip on my iron. Because these aren't exactly small points we're working with at the moment. Alright, let's see if we can work that off. Get my finger underneath it. We'll try heating that pad up go, that come out. Let's try the same on that one. There we go. That was a lot easier than I was expecting. Right. Pop that back over. Come on, off you come. I hope that's not a trace that's connected to the bottom of that glue underneath. Out you come. Oh no, thank God, it's just a little bit of glue that's trailed off. I thought when I was pulling that off it was actually lifting a trace off the board, but we have been a little bit luckier than that. But yeah, you can see that is what's caused all the damage. You can see around here the damage is quite, it looks quite severe to be honest, but let's have a clean up first. We'll probably have to pull off most of round here, actually pull the chips off to really clean properly, but for initial fire ups I just want to get rid of as much of this as we possibly can. At least then we can see what state it's in. Got in all these slots here. In fact, those are cleaning up really nicely. That's just coming straight off on them ISA slots. Try that one. Oh, lovely. So I think our ISA slots are going to be absolutely fine, and it only affected those three. And that's cleaned up really nicely. That's not to say we're not going to have to perhaps pull them off, but at least for the moment they're going to be alright. In fact, that's cleaning up quite nicely as well. Let the vinegar do its work. For those that aren't aware, the reason we use vinegar is that the corrosion on the board is actually an alkali. We use a mild acid. The mild acid neutralises the alkali. That's why it fizzes up when you put it on there. Two diodes here which are incredibly green. I mean, things like diodes aren't an issue, providing you can read the number off them. They're going to be fairly easy to replace, because they're either going to be Zener diodes or small signal diodes. They are actually cleaning up fairly well. My main concern is all the damage to these wires around here. There's traces here which look almost certainly like they've gone. Interesting thing is, the board with the silk screening on the board looks like it may have been designed for something like a CRC32, and then they used, I wonder if I've seen quite a few boards that you can modify. They could either use an external battery pack, or the board itself could be set up to use a CRC32, you know, coin cell, or a rechargeable battery like that, depending on whether you make a link which allows the battery to be charged on the board or not. So there could be a possibility that we can perhaps, you know, break a trace somewhere, put a CRC32 holder on there, and that would be pretty good. And you just have to change your battery every year or two when it goes flat, but them CRC32 batteries really don't leak. All these are going to have to come out, I think, but initially all I'm trying to do is get the worst of the surface corrosion off, so and neutralise it so it doesn't get any worse. I actually have bought some new toys for working on boards in this situation. A little engraver and a little multi-tool, but they're quite nice for this type of work because they're battery powered rather than with a transformer or mains powered. Which means that they're a little bit easier to use in small spaces without having the lead flopping about everywhere. Right. This is pretty bad. Tell you what I'll do is I will carry on cleaning this up, and we'll come back when I've really cleaned this area as best as I can, and we can actually have a think whether it's going to be feasible to try and power this board up, even if it's just with a postcard in it for now, see if there's any signs of life. Like I say, I'll be just give this a little bit more of a clean up, get it as best as I can, and we'll be right back. Right, we're back. As you can see, I've only spent about 20 minutes or so having a bit of a clean up round here. You can see I've gone through a fair few Q-tips there, and to be honest, it is looking a hell of a lot better. I've had to pull that IC there. In fact, the IC itself cleaned up really nicely. I think that's absolutely perfect, that's fine. The socket itself, there is still a little bit of green in there. That actually doesn't concern me all too much. A little bit more scrubbing and I'd get rid of that. What does concern me is I can see traces that go between that IC and at least go underneath that IC, if not to this IC, and I can see bits where the corrosion's got underneath the solder mask and it's going black. These traces are so thin, we could very well have some broken traces under there, so I think I'm probably going to have to, in fact I think I'm probably going to have to pull everything pretty much from round here to sort this out properly. And if you look over here, some of these traces are really badly corroded. These nice thick ones there, they'll be like +5, +12 volt rails. In fact, these all here, these big thick ones, they're all power rails because they go straight to the power connector there. They don't look good. They're going to need some work on them. Like I said, the DIN socket there, I'm pretty sure will have took the brunt of the corrosion. That socket, that IC there, will have to come out. One interesting thing I have just noticed though, we've got a tantalum capacitor there. I don't know if you can make out on camera, but that's blown its top. The top of that capacitor is completely missing. So I'm wondering, was that the initial failure that shut this computer down and ended up being shoved in a cupboard somewhere for probably 30 years? That will not have happened in storage. That's happened because that capacitor's shorted, it's been switched on and it's blown its top. So we've definitely got one part there that we're going to need to address. There probably is a short between ground and whatever that capacitor is. I think it's on the -12 volt rail. Looking at this, it's actually really well documented, this board, as in everything I can see on here has got like part numbers on it. Even these transistors down here has actually got the type of transistor printed on the board, and which is collector, emitter and base printed on the board, which is quite nice really. Again, with the power connector here, we've got all the 5 volts are all marked there, the grounds are marked there, -12 volts marked there, +5 volts marked there. You know, it's all quite nicely done. It's a chips motherboard, chips and technology, isn't it? So it's like I say, it's a fairly well regarded main board, because I mean I think the chipset's quite well regarded as a fairly decent, reliable chipset. So I suppose all I can really do is delve into this thing, and we'll start. Let's get the old desoldering station fired up, and we'll start getting some of these parts off, and then we can have a really good clean up around this area. Yeah, we're going to have to get that off because it's filthy, and it'll also help us clean up all these parts. We've got some of the parts that are really bad out of the way actually. But I can't see a lot of major damage on the back. It has come through, The most damage is on these wires, which have gone really green. There's a trace there that doesn't look too happy, but we might have got away with it. Just try using the end of the screwdriver just to break some of that corrosion up on that wire. Then we'll go in. Looking a little bit better, but it's not exactly looking good. Let's have a spray down and grab a couple of Q-tips. Get this cleaned off around here. Yeah, there are some traces even on the back here which aren't looking too brilliant. So I'm going to get you zoomed in a little bit more, see if we can see. Right, let's get you, there we go. Then we can make out, you know, there's traces here which seem to have got a lot of corrosion on them. There's traces around here, especially the one that's going to that wire. That doesn't look particularly good. I'm not as worried about the little bit of corrosion on like these big traces here, because there's enough meat there that even if it's, you know, partially corroded through, it'd still be fine, it'd still work. Let's try and get that keyboard socket off, and we'll try and get them IC sockets off. So I think we're yeah, that should be about right now. We'll put a bit of fresh flux on first. We might have to add some fresh solder as well, but we'll try just putting a little bit of fresh flux on first. Let's see if I can do this so you can still see what... Whoa! And not melt through the cable of my soldering iron, because that would be a silly thing to do. That'd end up with a flash and a bang. Right. Let's see about taking this connector off. This solder is really nasty. What we'll have to do, I think, is go in, get some of it off, then add some fresh, nice leaded solder. Let that dilute the old stuff a bit. Oops. Just a little bit of that's come out, but not a lot. So let's put you away for a second and get some nice fresh leaded solder. Get the soldering iron back where I can get to it. We'll have to change tips when I get onto working on the ICs, but this is good enough to get this socket off. That's starting to flow. You really want the new solder to flow down and mix with the old stuff, because it just makes it so much easier to get out. I think that went right down through. That one too, that was a good one. It If worst comes to the absolute worst, what we'll just do is cut the socket off, because I do have replacements. It'd be nice if we can save it if it's not too bad. So it's not the end of the world if we can't, because I do have replacements for them. Let me try and get... Very difficult after so long trying to remember to not cover the shot while I'm doing things like that. Oops. Try not to slip and damage the board. Go on. Going to need quite a few attempts, this, I think. It is not good. Now that one's come free. I'll still go at these two at the end. Most of that come off. A lot of that's come off. Don't think we're there quite yet. We'll have to go in, probably add a little bit more. Have a look on the other side. Yeah, the corrosion is horrendous. It's all the way through. So it's a case now of just rinse and repeat, rinse and repeat. So we will add some more fresh solder. And then we'll try sucking it out again. We could even try hot air and warm it up on this side with hot air and try pulling it out from the other side. That's another possibility. Let's try again with the desoldering station. I think we're still alright, don't think you need to empty that yet. So we have got a bit of movement on there. That's looking better. That's looking, oops. That's looking a lot better. Let me just unblock my, I think I've got a blocked nozzle. Yeah, only a little blockage, but that's all you need sometimes. That's better. And let's go back in. That's much better now. Right, so that's free, as near as damn it free. Same with, oh, that one's pretty much just snapped off, and that's how corroded it was, so we probably will end up putting a new socket on here, new DIN plug. Let us have a look. It is coming loose, that now, if you look. There we go. A little bit of a shake. Yeah, it's basically free. All the solder's free. It's just a little bound up in the board. Just very gently rock it. I'm not using any real pressure, I'm just manipulating it round and rocking it until it pops off the board. There we go. And we're off. Actually, it doesn't look too terrible. The corrosion's got to the bottom of it there. It has rotted off those front pins, but I could possibly just solder something on there. But if you actually look inside the socket, I don't know if you can make that out on camera. I can't see any green actually in the 5 pins there, which is the important one. They look okay on the back there, they'll clean up quite nicely. But I'm glad I took it off, because if we look at the board, it's pretty horrendous. There is a lot of corrosion around there. Let's give that a quick clean with just a little bit of IPA. Just see how well that comes up. But the reason we've took it off more than anything, there's no other way we could get to these traces round it, like that trace there that trace there, which was underneath the actual socket, and it does look very corroded at the end there. I may even in the next instalment on this pull the microscope out so we can really get down and have a proper look at these. Look at that though. But yeah, there is quite a bit of corrosion around here. I don't know how many layer this board is either. I'm hoping it's not like many layers. Like that A7000 that I've got, which is like 4 or 6 layers or something like that. It's an absolute nightmare to work on. Yes, even some corrosion all the way up there. It's got all the way up there as well. Oh well. It's all part of the fun of this hobby, isn't it? That capacitor there looks like that's absolutely fine. It's just that one tantalum capacitor there, which, like I say, it's blown its top. So very good chance that's why this computer, I said, was retired. It probably give someone a shock one morning when they switched it on and it went bang. So sadly, probably at that point there was nothing wrong with the barrel battery either, but that's what happens with these. So they get left in storage for many years and those barrel batteries leak, and this is the result of it. Just cleaning up a lot nicer than I was expecting though, I've got to say that. I think what we'll do, we'll have a go at getting that IC and that IC off, and then we can get the continuity tester out and we can actually start going around this testing continuity. I'm going to have to take these off anyway because I need to clean any of the corrosion that's underneath there, tin up the traces, because even if they've not failed now, if they've got that corrosion on there and it's not treated, it's slowly going to be corroding away them traces and it will fail sooner rather than later. So I know you'd expect me to probably be firing the board up at this point, but there's very little gain, to be honest, at the moment. I don't suspect any of the other chips to be bad. I suspect the reason, like I said, this computer was retired is because it had a shorted tant. It went pop, it probably shorted the power supply up, wouldn't power up, and like I said, it just got mothballed. So we might as well do the repair work we can see before we even, like I said, attempt to give this thing some power. So yeah, I think I'm going to take that that IC there off and that socket there off. So, and obviously I've got some clean up work to do around here. Get that on shot. I think I need to get some new tips for my desoldering station as well, because that does seem to be scratching the board a little bit, unless that's just crud around there. Oh, it's just crud around there, it's cleaning off. Yeah, yeah, no, it's just old baked on flux that it is cleaning off. Need to get some more IPA as well, I'm nearly running out of that. Yeah, that's looking better already. So anyway, I will get these ICs off and we'll get straight back once I've got them off, and we can start checking continuity and making sure what traces are broken and what are still good and they just need a little bit of preventative maintenance on them. So back in a sec. Right, okay, as you can see I've done quite a bit of work off camera. It's actually took me quite a while as well, because basically the solder is so corroded on here with the leakage. It's not just a case of grabbing the desoldering tool, pulling the solder out and just lifting the component out. It's not been that easy. It's actually took, like I said, a number of hours to get to this point. As you can see, I've removed that IC there, which I've got here, and that needs cleaning up yet. You can see all the crud on the legs there. And obviously I don't want to risk breaking one of the pins off or pulling a trace on the main board. So basically the process is scrape away some of the let's flip the board over so you can see. Basically scrape away some of the old solder so I can see a bit of silver, add some fresh solder to it, get this fresh solder to mix in with the old solder, suck that away, and basically rinse and repeat until the leg's basically free. In this instance, even that wasn't enough for that IC and the IC socket that I took out there. What I ended up doing at that point was actually getting my hot air rework station, have the board this way up and a little screwdriver under the IC, warming it from this side until the solder actually finally melted, and I managed to bring the two ICs out. And I said, fortunately I've done it without damaging a single through hole or anything, so I'm quite pleased with that. I will have to get a new, I would be replacing that anyway, but as you can see it did get a little on the warm side. Pulling that out it got a little bit deformed, but there's no way, I mean, yeah, if it was perfect I could throw that in my little ultrasonic cleaner, and I'm sure it'd clean up and I could use it again. But for the price of these, and I've got a box of them, I'll just put a new socket on when we're ready to get that far. I have also, obviously you've seen, I've taken the keyboard connector off, but that's absolutely fine. That can, again, I might just throw that in the ultrasonic cleaner just to get that little bit of crust that's in there out. But the pins themselves, I've checked continuity between the pins and the pins at the back, and there's absolutely no problems at all. So I'm quite happy to reuse that. I'll just have to make some new little pins for the front of it to mount it back down, because those broke off when we took it out the board. I also removed that 8-bit ISA slot from, well, it's actually part of a 16-bit ISA, it's the front 8-bit part, from there, because there was a lot of corrosion basically under this part of the IC socket. Another reason, I actually took the little jumper blocks which were there and I removed them as well, because the corrosion's got all the way up in here. So much so that some of these, even with a pair of pliers, I couldn't get them to separate. The ones that I did get to separate, there, you can see how horrendously, I don't know if that's going to focus. Well, come on, focus on that. But basically the corrosion's got all the way up in there. I'll put new new jumpers on the top because they'll all be corroded inside. I could throw them in the ultrasonic cleaner and see if they clean up, to be honest. I might do that. But yeah, so that's basically where we're at the moment. I've got all them parts off. I've removed that tantalum capacitor as well, which seems, I don't know where that's gone actually. It should be on the bench somewhere. But I took that tantalum capacitor out, which had blown its top. It's actually only on the minus 12 volt rail, so to be totally honest, the computer will probably work absolutely fine without it. But I have ordered some new tantalums. There are one or two on this board. This board's from what, 1989, I think we figured it out. There's a good chance some of these tants are either shorted or they're not far off, so I'll probably replace them all. I think these are 22 UF and the smaller ones are 10 UF, so I've just ordered a few. I needed some anyway for the XT motherboards that I'm working on, so and one day I will recap my 5150 as well, so I have ordered some of them. They're on their way, but that won't stop us actually getting the board up and running. Like I said, it's only a decoupler on the minus 12 volt rail. I actually, last night, because this is the following day, I did watch a video on YouTube of a chap actually repairing this exact same motherboard. Now, his corrosion didn't look anywhere near as severe as the corrosion that I've got on this one, but he still ended up taking off pretty much all what I've taken off, apart from I don't think he took the ISA slot off. But he removed that, you know, the keyboard connector. He had to remove both those ICs, those diodes, all the transistors, everything around here, because the corrosion had crept up that way. I think he even took the power connector there off, and he had to do multiple trace repairs on it. There was a lot of trace repairs on it, but he did get the board up and running, I think. I will probably have to take those off as well, but for the moment we'll concentrate on this area here, because this is the worst of it really. Now what I want to do before I start tracing out is see if we can get rid of some of the damaged solder mask around here and expose those traces, and then we'll have a really good chance of seeing what is and what isn't working. I did already just have a really quick flick around with the continuity tester, and I've already found broken traces, and the traces that you wouldn't expect really to be gone. So I think there's going to be quite a lot of trace repair on this board. I'll just switch the old tester on. I've got the reason I'm using this one is because it's got an audible continuity buzzer on it, unlike the one I normally use, so you could all hear it. But some of these big thick power traces here, I mean, I did scrape a little bit. Let me get you down a little bit so you can see more what I'm actually showing you. Ooh, and then we'll come down like that. Right, there we go. As you can see, I did already start by taking a little bit of the solder mask off there to see if I could find clean copper. Now we've got I think that's probably like either a 5 or a 12 volt trace by the look of it. It goes to a capacitor there. Now if I go follow it down somewhere, there's a solder point on it there. If I go to here, so we've gone from, let me get you across a bit, so we're all the way over there. I'll get you out a little bit. Oops, there we go. There, you can see better now. So we're all the way over here on a via. As you can see, that's basically, I'm just testing between that via and that via. We've got continuity. If I go on a bit further to where I've scraped that bit of solder mask off, we've got nothing. So we've got a break between basically there and there. That's the first one that I've found. I believe the same with this trace here. If I go on that point there, on that trace, which is this trace here, even if I scrape, in fact we'll Let's try and go a bit further. Let's follow that trace round. That trace goes to this point here. That trace is bad. Oh no, hang on. Oh, we've actually got a... that one's working, I think. Yeah, that one's good. That's absolutely fine. So at least we've got one there that's alright. We could try this trace here. It goes through that capacitor. That's the next big thick trace. And these, like I said, these are power rails. And that one's good. So we've got one out of them that's bad. Then we've got some even smaller traces around here that were actually underneath the battery. I think those are bad. I found at least one on the keyboard connector when I was just flicking around. I think it was that one there. Oh no, that one's okay. It must have been that one. I know one of these. Yeah, that one's bad. So we've got quite a bit of repair work to do in just that area. Like I said, what I want to do first really is see if I can get some of this solder mask off so I can actually get down and see quite how bad it is. Now, I've got a couple of options for this. I've been buying toys. I bought these a few months back. First thing is, and I don't know whether... I've seen some other people use these for this exact job. We've got a little engraver tool. Now these were only cheap. I think this was like 12 quid or something from Aldi. I think I got it on the clearance section. And what this is really designed for is engraving into metal and things like that. Comes with some little stencils and things in a USB-C charge lead. But unlike the big mains powered ones, this is actually quite gentle. Basically the end of it there, I mean, you can see I can keep my hand on it, it doesn't damage it. It's got different power settings. We'll have it on the absolute minimum setting. And I have seen, like I say, I have seen other people use these for this. And basically the idea being you just use it to clean away the damaged copper like that. You can see it actually does a fairly reasonable job of removing the solder mask and the oxidization on the top of the copper. I would issue caution though, because you press on too hard, you're going to basically erode the copper all the way and you're going to break the track. It's one of these things that you practice on some scrap boards before you go on anything that you actually care about. But we've got that one. At the same time, so these were all in the clearance section basically at Aldi. I'll put that away. I also got this one. This is basically your standard rotary tool, like a Dremel kind of device, but again it's cordless, which makes it really handy for this type of job. And it comes with a nice little accessory kit as well. And what I was thinking, there's a few things in here that might do the job, but what I was looking at was this little wire brush here. Now I'm wondering whether this would be ideal for just taking off a lot of this solder mask. So I thought we'd give that a try. I'll put that in the end there. And again, like the engraver, it's got power settings on it. So we switch it on and we can turn it like right down. I mean, look, I can hold that against my finger. It just very, very gently, just slightly scuffed my finger, but it's not exactly cutting into it. And I was wondering whether this would be ideal. Perhaps you have to go up a little bit. It does seem to be working actually. Cut through that corrosion. So I'll just have a good 10 minutes now. Just see how much of that I can actually clean off, and we'll come back when I've got it's a bit cleaner than it is. And we can then have a really good check, see how many tracers we've got in this area that we're actually going to have to repair. And then I think we're probably going to have to move up here, because I know the other chap that was working on one of these definitely had tracers underneath these ICs that were iffy as well. Right, so I'll crack on with that, and then we'll come back and have a bit of a look, see exactly what we've discovered. So back in a sec. Right, I've been basically cleaning up as much as I can here. You can see I've cleaned those tracers off, and apart from damage to that bottom one there, I can actually get continuity on them two all the way through from basically the pin there onto the end of the ISA bus there. So I know they're good. That one is a different story. That's got I think at least two breaks. I can see some crust there, and I can see some crust there. I can get continuity from basically that capacitor to around here, but I can't get it from there to there, and I can't get it, and I can't get it from there, from there over to there. So like I said, I think I've got two breaks in that trace. These tracers down here, I've checked the bottom one there, that's good. The next one up's bad. The next one up, it disappears off underneath an IC, and I can't see where the other side of it is. So I think I'm going to have to lift those two ICs as well. This way, the keyboard connector, that one's good. That one there, the break is actually right at the via there. I can get continuity from there all the way right to there, and then I lose it when I touch the actual via there. So I'm hoping a bit of a clean up, a little drop of flux and a bit of solder, and that'll fix that one. And there's possibility there's some others that are going to be just like that, where it's really minor and a little bit of a reflow, a little bit of a tinning on them, and that should actually fix them. It will also, you know, prevent really flaky tracers which are working at the moment, and you know, a few microns of copper away from failing. Actually, you know, it'll reinforce them and give us a bit more life out of them. Then we've got, like round here on that IC, and go from there, follow it, trace it, and it goes to that via there. That's good. I think I've already done all these up here. Even though there was a lot of crust and corrosion around here, there isn't actually seem to be that much trace damage. Most of the trace damage seems to be in this area here, fortunately. I did need to take them off anyway, because there was so much of that corrosion actually like underneath that socket, underneath that ISA slot there, that it's better to get them off, sort it out properly, and then reinstall them. And obviously I'll put like that IC there, I think that was the keyboard controller, but that IC there was straight on the board, that wasn't in a socket, so obviously we'll add a socket for that. That already had a socket, so that'll get a new socket. Basically any IC that I have to remove from the board, I will put a socket in its place, because it just makes work on the board easier in the future. So next thing I'll do is I'll probably lift those two ICs there, so I can actually follow them other tracers out. And then when they go back on again, they'll go back in sockets. I've just noticed actually, it's really green down that side of that IC there. What is that IC actually? That's a should be just some 7400 logic, I think. That's what that is there. So anyway, we'll pull them off, and we'll make sure we put them back in the right places. But we'll pull them off, and then we can carry on with checking all these tracers out, and then like I said, we can actually start looking at repairing the tracers. I'm not sure which is the best tool to use actually. This works really well. This is what I've used to uncover those tracers there where I thought there was some damage. Thing with this is, you're going to have to practice with it. If you was to just go in on a board that you really cared for and you never used this before, you're going to damage the board. you've got to have it on the minimum setting and be incredibly gentle, and literally just like you would if you was engraving, just follow along the trace that you want to expose, and it will take all the solder mask off, and it will clean any of the oxidized copper away as well. But if you push on too hard, you're just going to obliterate the trace. You're going to gouge into it. Like I say, super careful if you're going to try using something like that. The wire brush actually doesn't seem to do as well as I was expecting for this, or at least on this board. It'll polish the traces up, and it'll get the blackness off them, but it's also, because it's little wire brush, it's scratching the board a lot and discolouring the board a lot. So I think actually I am probably going to, just with extreme caution, just use the little engraving tool to expose any of the traces that I need to before we start actually repairing it. Anyway, I'll go off now. I'll pull those two ICs. I might pull that little pin header as well, because I think there's some traces that look a bit crusty around there. I'll get that done and we'll come back and we'll carry on looking around this and seeing exactly what traces we need to repair on this side of the board. Once we've satisfied with this side of the board, obviously we've got to do the same on this area here, and I don't think it's actually quite as bad. I think we've been really lucky here. What I have noticed though, and I don't know if this will come out on camera, this is definitely a bare minimum of a 3-layer board. Because if we look at the keyboard connector here, I can see traces. If you see there, there's a trace there coming along there. It goes underneath that trace and it comes out there. Now that is a trace that's between the top layer and the back layer, so that's an internal trace. Say that's that's rotted out there. Really, because it's an internal trace, we'd have to start grinding away at the board to get to it to repair it, or we'd have to run an external jumper wire to fix it. Now that's all well and good when you can see where the trace goes. There's lots of these traces inside this board. You haven't got a clue where they're going to actually go. If it's that bad, then I think the board's probably no good. But I think in this instance, because it's only minor, it's only in this area, we should get away with it. But that's the issue I've got with that A7000 that I've been playing with. That's a multi-layer board. The corrosion's got inside the board, and I think it's actually broken traces inside the board. That's why I'm not having a lot of luck with that. Anyway, actually, I'll get off now. I'll get these out, and we'll come back and we'll see about tracing out any more of these broken traces that we need to. So back in a sec. Right, okay, I got those two ICs off there, and actually those come off far easier than round here where I had to, you know, really suck at them, reflow it, then even resort to hot air to get those off. Quick dab with some fresh solder and a quick go with the desoldering gun, and they actually came straight off, no problem at all. I've already had a quick buzz around, and fortunately it doesn't look too bad under there. Just get the old meter in here now. Trying not to burn something down with the desoldering gun because that's still on. What I have found, this let me see if I can get you across a little bit so you can see a bit better. Let's get you in a little bit. There we go. Right, okay. Now what I found, I've checked all the traces on this top IC there, and those are all fine. I've found one down here, and it's really annoying actually. All these I've checked so far have been fine. I got right down to the bottom pin here, which goes to a via which is underneath these two diodes here, and you can see my meter's working. If I go onto that via and onto the pin, yeah, it's the one and the whole lot that's open circuit is the one that's underneath those two diodes there. So sod's law, isn't it? So we're going to have to take those two diodes out as well, and we might as well take that pin header off at the same time, and we can have a better clean up there I mean, we may take them transistors off. I don't know about that yet, because there's a bit of green still under there. We could possibly clean that off, take them transistors out and do that. It's a case of how far do you go when it's a board like this. We're getting to the point where we're pretty much going to strip this entire quarter of the motherboard here. But I suppose, you know, if you want a good repair that's going to actually last, that's really all you can do. If you leave corrosion there and you don't treat it, eventually it's going to eat away. It's going to make the computer stop working again, even if it, you know, works when you first fire it up. You might have noticed here, I've actually just been playing around a little bit. It's a technique I've seen. I've tried it before myself, but not for some time. It's a technique I've seen Gadget UK, a few others use actually. Basically, where you just tin where the copper, where I exposed it, and use the engraving tool to basically clean off all the corroded copper. I've just tinned over the top of it there. This was just a quick experiment. I'll probably go over some more of the board where it's exposed like this and see what I can do about sorting it out. But the idea is, put some flux on the board, get your board some flux on, then take a piece of used solder braid, basically drop it on the board like that, take your iron, preferably with a nice flat bit on it. I've been using actually quite a large bit if you look there, but it's got a nice flat end on it, and basically putting it on there like that, moving it around over the exposed copper, and you'll just leave a very thin coating of solder back over them traces, and it'll not only protect the copper, it'll also beef it up a little bit where it's obviously been worn down by the corrosion and by the fact you've used an abrasive method to get rid of that corrosion. So like I said, I was having just a little bit of an experiment there, and deciding whether I wanted to go ahead and perhaps do that over some of the damaged parts. Also, I have at least fixed one trace. I was just having a quick play about, and basically on the keyboard connector here, if you remember, there was one trace there that was out. I just took a tiny little piece of wire, just scraped away at the end of the trace there where it was broken, and just bridged it to the via there. I think you can make that out just there. It's not perhaps the neatest of jobs, but I'm quite happy with it. It's certainly remade it because I'll be able to get continuity from there to underneath the board on the back of that via, so and then indeed across to another via that traces off to. So I'm perfectly happy now that at least that's repaired. That one we know is alright. I think there's a couple on the back we're going to have to check when we put the keyboard connector back on. But for now, let's get those diodes off, and I'm not actually sure if they're both the same. They're probably both just like small signal diodes, but there's a possibility one could be a Zener. Doubt it, but what we'll do is we'll take them off and we'll make sure we don't mix them up. So we'll take one off, we'll put it safe, then we'll take the other one off and put that safe. They're both orientated towards the back of the board, so we can easily remember that. We might as well get that done now, then we can have a look at repairing that trace. Right, so let's get the board flipped over. We are going to be, where are we now? We're going to be here, because that's that pin header as well. We might as well pop that off at the same time, and like I said, it'll help us while we're cleaning up around there. So let me get you so you can see that a little bit better. I'll have a quick slurp of my coffee. First thing we want to do is take some solder. And we just want to flow some, my iron a quick clean. You just want to flow some fresh new leaded solder over. Sometimes when they're really crusty you even have to scrape at them before you can even do this. I think I might get away with it on these ones. Basically the battery corrosion, it stops the solder flowing very well, so you need to basically add some fresh solder and try and dilute down that crusty contaminated solder. And we'll start with this first diode here as well. Not a lot of that leg sticking through, to be honest. And we'll go in with the desolder pump. Let's have a go at that diode. Oops. Right. Put that desoldering station safe. Let's flip that back over. It's still quite well attached there. Let's have a look at the diode, see if we've got the diode free. Just try. That leg's free there, and that leg's free on that side there. So this is the diode that goes towards the back of the board, so we'll lift that out and I'll put that at the back of my thing there in the same orientation so we don't forget, just in case these diodes are different. So I think they're both just probably small signal diodes, but rather be safe than sorry. I said we'll take them out and we'll lay them in an orientation, and we know they're going to go back in exactly the right place. Right. There's a bit of solder. Okay. Just add a bit of fresh solder to that diode's legs. Like that. And I'm just going to go back over them legs for that pin header. I suppose that is fairly close to where the battery has been, where the battery's leaked, so let's go back in and have another go at that. We'll take that diode off while we're here. Oops. I think, oh, I've got something blocking my just see if I can unblock my desoldering tool. Right, let's try that again now. Yeah, that's okay, that's free. Right, let's see if we can get that diode out. Oops. Yeah, it's free that side. It's still held on that side. Let's free up that side there. Right, let's get the other soldering iron. We should just be able to drop that out now without any problems. Yeah, there we go. There's the diode out. Let's get a bit of solder off it, and we'll put that there so I can go back in after. I've just got to clear the excess solder out of that hole. There we go, that's clear. Let's see if that pin header will come off now. There we go. That's the pin header loose. We'll just pop that off because we might as well just replace those. I mean, we could clean them up, but it is just a piece of pin header. I've got strips and strips of that, so we'll probably just put new ones in. And it gives us a chance now to be able to clean that bit of the board that we couldn't get to otherwise. In fact, shall I take those transistors out as well? Because this one in particular is looking mighty green underneath it. I think we could probably, yeah, let's do it. Let's take these other components off, and then we can clean up round here properly. This is going a little bit more than I would have normally, but seeing we've gone this far, we might as well do that as well. So let's start with this first transistor, and I don't think, yeah, I think these are two different transistors as well, so we'll have to make sure we put the right one back in the right place. Oops. So, again, let's add a bit of fresh solder. Might as well do these resistors in that at the same time. Right, there we go. Let's see if we can get these out. Try that first one again. I don't think that's quite got that one. Right. That's that first transistor there. So we will take him out of the board, and yeah, the legs are looking rather crusty on that, so we'll give that a good clean up before he goes back in. Unfortunately, it's marked nicely on the board. This board is quite easy to follow. Just hope we don't scrape all the markings off while we're repairing the traces. We might as well get that resistor and that diode off next. Oops. Right, let's see if we've got them this time. Just see if we can rock that free. It still feels fairly well fixed yet. These are quite green and crusty, so I think the corrosion has affected them a little bit more. Let's have another go at we'll put a little bit of more fresh solder on. Wherever I've lost it, there it is. I was hoping to do all this in one video, but it's got such involved. I think this may end up having to be a two-parter, I'm afraid. Right, there we go. I'll give that another go. That's better. Right, I think we got it that time. Obviously, like I say, I want to try and keep these parts all in order. No, that still seems to be well attached. Yep, that's still very much attached. The problem is there's not much leg actually sticking up there, so you've not got anything to really whittle against. You've cut these very, very close to the board. It's actually better when you've got a little bit more leg sticking up, so you've got something to whittle. Oh well, where, oh, there it is. Thank God for that. Okay, so we've got the resistor out anyway, so I'll put the resistor up there like that so we know where it goes. And how far is the close is the diode to coming off? That's still seeming quite well attached yet. So let's go back in, let's get rid of that while we're here. So another go at this leg of the diode. I think we might have to try adding some fresh solder again to that. I think it's just crusty solder that's right down there, and we need to try and get some nice fresh solder in to help flow it out. There we go. Put a big blob on. Then when we heat it up with the desoldering tool, it's got some more mass there basically to flow through, and then when it's all liquid we can try and suck out the whole lot of it. So let's try that again. Can you see what I'm doing here? I hope you can. It's there we're working. Keep forgetting that I have to keep the what I'm working on in shot. Right, let's try that this time. It's still seeming quite well attached yet. I don't want to risk using too much force because obviously it's a glass diode. I don't want to break it, especially as I might not have a replacement in stock. Let's try the other way of doing this. What we're going to do, we'll put a little bit of force under one leg with a screwdriver like that. I'll take my iron, use it nice and flat, and we'll just heat up. Oh, there, popped out. Popped out before I even got that on it, to be honest. Let's clear that hole out while we're here. There we go, that hole's cleared out. The diode's popped up like that. It is literally just held in that hole. That's already loose there. Let's help him out. And there's the diode out. It goes that way up, like, well, it shows it on the board. So in fact, even on the board, if we look down here, we've got a symbol for resistor, symbol for the diode, so we can't get them mixed up and put in the wrong place. I say it's quite a nice board in that respect. It is really well marked. Let's get that last transistor out, and then at least we can have a really good clean up of that area. Right, are you going to come out? No, that's going to need a little bit more work on it before he's going to come out. Again, where's my solder? We'll just add a little bit of fresh solder and we'll have another suck, and hopefully it'll come out this time. I'm sorry you can't actually see. Let me try doing it with the other way around so you can actually see what I'm doing. I keep realising that I'm blocking the shot with my hand. Oops. Well, apologies there, slight camera issues. My memory card went full, but anyway, we're back onto it. You've not really missed much. I've got that transistor out there, and actually before I realised the camera is, I've just basically cleaned up them components. I got a screwdriver and give them all a little bit of a scrape like that. Just get any of that corrosion that was on them. I should really replace them, but I'm not sure I've got exact replacements in stock, and I don't want to have this hanging about on the bench for too long. So they've cleaned up fair enough. They can go back in. Like I said, I will probably change all the pin headers because they're all got a little bit of corrosion on them, and that one's actually not terrible, but the ones for the jumpers down there, they definitely need replacing, so I might as well replace them all. Like I said, I've got plenty of pin header in stock. Now, what I've just been starting to do, basically, I've got my fiberglass brush here, and I'm going round now all the places we can now get to with the fiberglass brush, cleaning it all up, like them vias there that we know we need to do a little repair. If we can get it clean with the fiberglass brush, basically, you know, it's going to make our life easier when we need to solder a little jumper wiring to replace that damaged trace there. In fact, that's probably the first repair we're going to do. But what I might do, actually, I might go and get my microscope so we can zoom in this, and it'll actually make it a little bit easier for me to do this work. But so far, like I said, I've tested, I think, all these traces around here, and everything else seems good. I've just got a few of these left to just check on this side, and then hopefully everything should be good. We can tin up what we need to tin up around here, and then we can actually start repopulating the board. That might be in the next video, though I'm not sure, because this is already getting really quite long. So I'll get the microscope set up and we'll be back in a sec. Right, as you can see, I've got the magnifier here. I've got to be careful not to shake the desk because this thing is a little bit. You shake anything, and obviously the image shakes. Now, this isn't really like a microscope or anything. What this is actually intended for is short sight. You know, people that have got sight impediments. You used to have them in schools and places like that for people that couldn't read books, so you put your book underneath here and it'd magnify it massively on the screen. They're actually really quite expensive. Like I think some of these are over £1,000. I was really lucky. I picked this thing up for like 20 or 30 quid on eBay a few years ago, and it's really handy for doing this type of thing. Plus, it's a much bigger screen than you get on the microscopes that you buy, at least the ones that are affordable on eBay and places like that. This is, like I said, it's much bigger. It's a 17-inch screen, I think. It's either 17 or 19 inches. Quite a nice, decent screen. And to be honest, all that is a VGA monitor. So you could replace that with pretty much whatever you wanted, provided it can do 1024 by 768. It'll work for it. But yeah, this is basically what I use, because I'm not spending a load of money on one of them fancy little microscope ones. So what I thought we'd do, like I said, I've got it all set up now. I'll get you zoomed in a little bit so you're perhaps just seeing a bit more of the actual screen. There we go. Let's try and get to the end of where... now where are we going? Where are we going? Here we are. So there we go, that's a good example. So this is about as far away from where the actual battery corroded as we can get on the board. And let me get something to point with. We can see even over here, even though these connections are still actually made, you can see that there is bits of corrosion. Like there, if you look, you can see where that through hole is. There's a little bit of corrosion there, possibly a little bit there where we've got a connection between those two pins. Again, there you can see a little bit of green. This is, I probably need something a bit smaller than this screwdriver that I've got in my hand at the moment, but you can see it there. You can see where the corrosion's affected that pin there. It's basically eating a lot of the top of the through hole, the through hole there. away. It looks like there's enough copper there that should still make a connection, but this is basically what we're looking for. That's why obviously this microscope is so much more useful. Now I have already checked all these and they are actually all at least connecting, although that one looks a little bit suspect there. If you can see between those two pins there should be a connection, and that looks like it might be broken there. That one I know I've chased down and that one's okay. I know that one there is okay, although that looks a little bit dodgy there, to be honest. But actually I think I might have missed testing that one, so we'll do that right now. Well, we've got it on the screen, so we'll get my tester in. We'll set that to continuity mode, and we'll come down here and we'll just test between that pin there. Oh no, and we do have a connection, fortunately. It just looks a little bit dodgy there. In fact, that's loose. If you look there, when I push down on that yeah, that's not a good connection, because that actual trace there, when I push down on it there, I can see it moving slightly. It's loose. So even there, even though we've got a connection, it's not sound. I mean, when we flow, well, I'm not going to put the ICs straight on, I'm going to put a socket in, but when we flow in, that could break loose and we'll lose that connection. So we'll have to reinforce that. Like I said there, that looks a little bit suspect, so we'll probably have to clean up a bit there and reinforce that. Most of these look alright. That needs a bit of solder sucking out from there, otherwise the socket won't go in properly. Little bit of damage there, little bit of damage there. Again, we'll probably have to just reinforce that a little bit. These look okay. Can't see much damage there. In fact, they look fine, them wires. But all around the board, this is basically what I'm going to have to do. Again, there you can see it's a little bit crusty. We'll probably just need to tin it up just around there. Where that transistor is, that looks nice. Perhaps a little bit crusty around the middle, but I think there's still enough copper there to make contact. Again, where that resistor we took out is, looks a little bit crusty around there, but it's probably absolutely fine. Same with that diode. Let's move down the board a little bit. So we're on to that second IC. This is again closer to where the actual corrosion is. Again, I've tested this and this is okay. We've got a little bit there that's a little bit dodgy, but I think that should be okay. Again, we've got a little wire there going between those two pins. I'm not sure whether I tested that, so we might as well just quickly test that while we're in here. So we'll go between that pin there, yeah, and that's okay. And then we've got, of course, this one down here, which is the one that I think is that I think we decided was faulty. So we go on to there, and we go on to that via there where it should connect to. We've got absolutely no connection there, so we've got a break somewhere between there and there. And to be honest, it looks like the break might be there. Let's see if we can get a connection between there and there. Nope. Let's try and break a little bit of the solder mask off. We'll see if we can get a connection between there. Yeah, that's okay. When we go to the end over here where that is, no, we've got, so our break must be here. So we'll probably have to scrape a little bit of the, oops, let me move that. Get out of the way. We'll shut that off for now. So our break must be around about here. Let's have a little bit of a scrape away there, see if we can see anything. We might get really lucky and just be able, in fact, have I got a soldering iron that's warmed up at the moment? I don't think I have. I'll pulled everything out of the way so I could get the screen on the bench. I think we must have a break somewhere around there. You can see how this solder's been affected. It just kind of like crumbles away. So we'll reflow that. Let's just have a quick look, see if we've got anything there now. So it's there. So the break must literally be right at the end there, because if I touch right on there we've got nothing. If I bring it this way, it's there. So that's where the break is. So hang on a minute, let's just see if we can get the soldering iron out. Of course the soldering iron is buried behind here. Ooh. How am I going to do this? So just bear with us a second folks, I'll be right back. Right, okay, we're back. And I've switched to my Antex iron here. Mainly because it's got a really fine tip on it. If you can see how small that tip is. And what I'm going to attempt to do is just see if I can just basically get a little bit of solder on there and just bridge that break. Now this might sound counterintuitive. Yeah, I think that's about right. But what you don't want to do is put some flux, liquid flux on the board before you try and do this. Because the thing is with flux, if anyone drag solders, you know, when you're putting a surface mount IC on, you always put flux on the board, and then when you heat it up, the solder flows basically away from where there's no metal. Now what we're trying to do is we're trying to bridge between that point and that point there, and if we put flux on the board, it's going to try and want to break that into two separate beads, and that's not what we want. We want to actually try and create a bridge across there. So we're just going to rely on the flux that's basically built into the solder. If we come in and basically we'll add a bit of solder there, pull it away. I think we've got a connection there. See if I can just neaten it up a little bit, because that looks a little bit messy. Let's have a look at that now. Let's go in with my finger. Yeah, it's a little bit high, that. Let's see if we can get it like that. That's not too bad, it's a tiny little bit raised, but I think we may have got a connection there. So let's go in with the tester and let's see if we've actually repaired that. We're going from there. Yeah, there we go. So we've got connection back to that via there. So that's one done. So basically I've got to now go over the rest of the board. We've already checked that, we've already established that that's all okay on that IC there. Again, we've got that transistor up there, that looks all good, okay on this side, so most of the connections on these must be on the other side, or they must be internal. We're up to, oops, let's go down that way. There we go. So we've got that battery connector next, which was basically there. That was right near where the corrosion was. And I've noticed some corrosion on that trace there. There's some corrosion on that trace there. That goes to there. So it must be okay. But I might just want to just scrape that back a little bit there and just make sure it's okay. Again, same with that there. I'm pretty sure we've checked that goes, yeah, because that goes to that pin there. I've already checked that one and it actually works, but we can see there's some corrosion around there, so we need to clean that off and just make sure that's alright. Same there, if you look, there's some corrosion just where it enters there. So again, we need to clean that off and just make sure it's okay. I can just notice the via there, that's the same. We just need to have a clean off there and make sure it's alright. Again, same with there where there's been some corrosion. I've cleaned it off. Perhaps tin up that area just to make sure it's okay. But to be honest, we'll do these in the next video, because I just realised this video is already quite long. So basically we've got the strip down phase, the cleaning up of the actual corrosion phase pretty much done now. It's now a case of just making sure everything's okay, and then we can start putting components back on the board, and that's what we will do in the next video. So I hope you enjoyed this start of the repair of this board. Fingers crossed we can get it working and we can get this computer all back to how it should be. So I will say thanks for watching and goodbye.